Hello students, welcome back to the mathematics class. In the previous video we have discussed about the Lagrange's mean value theorem for two variables. Here we will discuss about the Taylor's theorem for two variables. In the B.sc first sem you have already studied about the Taylor's theorem for a single variable. So here Taylor's theorem for function of two variable is if f of x comma y is a function of continuous partial derivatives of nth order, then f of a plus h comma b plus k equal to f of a comma b plus h into dou by dou x plus k into dou by dou y into f of a comma b plus 1 by 2 factorial into h into dou by dou x plus k into dou by dou y whole square into f of a comma b plus so on plus 1 by n minus 1 factorial into h into dou by dou x plus k into dou by dou y whole raised to n minus 1 into f of a comma b plus so on. So in the B.sc first sem you have studied about the Taylor's theorem for single variable. So according to that, the function that is f of x equal to f of a plus x minus a into f dash of a plus 1 by 2 factorial into x minus a whole square into f double dash of a plus so on. So now we have to prove, that is we have taken here a plus h because this x is less than or equal to this a plus h and this y is less than or equal to b plus k, and this a will be less than x and b will be less than y. That is the given condition. A is less than or equal to x is less than or equal to a plus h and b is less than or equal to y is less than or equal to b plus k. So what we will write this given equation as, that is f of a plus h comma b plus k equal to f of a comma b plus h into dou by dou x means function with respect to x plus k into dou by dou y means function with respect to y plus 1 by 2 factorial h square f this is h into dou by dou x plus k into dou by dou y whole square. So this is about the a plus b whole square formula. So they have applied here, that is h square function with respect to x 2 times with respect to x function 2 times with respect to x plus 2 into h into k function with respect to x and with respect to y plus k square into function with respect to 2 times with respect to y plus so on. So this is the given equation. So in this equation we will put some x equal to a plus h and y equal to b plus k, that is x equal to a plus h, y equal to b plus k. So x equal to a plus h and y equal to b plus k, then h will be x minus a and k will be y minus b. Then this equation becomes, this above equation becomes, that is f of x comma y, instead of a plus h we have taken x here and b plus k, instead of b plus k we have taken here y. So that is f of a comma b plus, that is instead of h we have taken x minus a and function, that function with respect to x of a comma b plus instead of k we have taken here y minus b, that is the function of a comma b with respect to y. So plus 1 by 2 factorial, instead of h we have taken x minus a whole square and function with 2 times with respect to x, that is of a comma b plus 2 into x minus a y minus b, that is k y minus b, that is function with respect to x and y of a comma b plus y minus b whole square, that is k square, that is function 2 times with respect to y, that is of a comma b plus so on. This is the Taylor's functions for function of two variables. So next we will study about the maclaurins theorem for function of two variables. Maclaurins form for the function of two variables. We know by the Taylor's theorem, that is f of x comma y equal to f of a comma b plus x minus a into fx of a comma b plus y minus b into fy of a comma b plus 1 by 2 factorial x minus a whole square f 2 times with respect to x, that is f of a comma b, plus 2 into x minus a, y minus b, f with respect to x and y, and of a comma b plus y minus b whole square, f 2 times with respect to y of a comma b, plus so on. So the condition is a should be less than or equal to x, and x should be less than or equal to a plus h, and b is less than or equal to y, and y is less than or equal to b plus k. So what we have to do here is put a equal to 0 and b equal to 0 in this equation. Put a equal to 0 and b equal to 0 in this equation. That is f of x comma y equal to f of 0 comma 0 plus x into fx of, here this 0 means remaining is only x, that is x into fx of 0 comma 0 plus y into fy of 0 comma 0 plus 1 by 2 factorial into x square into f x 2 times, that is the function with respect to x 2 times of 0 comma 0 plus 2xy f xy function with respect to x and y of 0 comma 0 plus y square into function with respect to 2 times with respect to y, that is of 0 comma 0, and further if we continue that is 1 by 3 factorial. This will be now x cube function 3 times with respect to x, that is of 0 comma 0 plus 3x square y into function 2 times with respect to x and 1 time with respect to y of 0 comma 0 plus 3 into x y square f into function with respect to x and 2 times with respect to y, that is of 0 comma 0 plus y cube into function with 3 times with respect to y of function 0 comma 0 plus so on. This is the maclaurins form for function of two variables. And next we will continue with the examples on maclaurins form or Taylor's form. So they have given here expand e raised to x sin y by maclaurins form of third degree. So we have considered that is the maclaurins form, that is f of x comma y equal to f of 0 comma 0 plus x into fx of 0 comma 0 plus y into fy of 0 comma 0 1 by 2 factorial x square 2 times with respect to x, that is of 0 comma 0 plus 2xy fx f xy function with respect to x and y of 0 comma 0 plus y square f 2 times with respect to y, that is 0 comma 0 plus 1 by 3 factorial x cube function 3 times with respect to x, that is plus 3x square y function 2 times with respect to x and with 1 time with respect to y, that is of 0 comma 0 plus 3x y square function with respect to x and 2 times with respect to y, that is of 0 comma 0 plus y cube function 3 times with respect to y of 0 comma 0 plus so on. So what they are given here, we have considered that is function as f of x equal to f of x comma y equal to some e raised to x sin y, e raised to x sin y by the maclaurins form. So by the maclaurins form, if f of 0 comma 0 then 0 comma 0 equal to the function with respect to x, that is function with respect to x, this function with respect to x. With respect to x means we have to, if we differentiate with respect to x, e raised to differentiation of e raised to x will be again e raised to x, and this sin y will be constant, we can write as it is. So your function at 0 comma 0 means as x will be 0, here x will be 0 and y will be 0, x is 0 and y will be 0. Then if x is 0 and y will be 0, if x is 0 then e raised to 0 will be 1, if y is 0 means sin 0 will be 0, then the function will be 0. So now this function will be 0. Next we want that is function 2 times with respect to x. We have already differentiated this function with respect to x, so again we have to differentiate this function with respect to x. If we again differentiate this function with respect to x, that will be again e raised to x sin y, because with respect to x means again this will be e raised to x and this is the constant term, we can write this as it is. So again function, this function, that is will, if you put x as 0 and y as 0, if you put x as 0 and y as 0, again this function will be 0. If you put x as 0 and y as 0, again this function will be 0. So this value is also 0. So next we'll see, that is function with respect to x, that is 3 times with respect to x, that is f x and x. That again we have to differentiate this function with respect to x. Then it will be again e raised to x sin y. So the function 3 times with respect to x, we will, if you take x as 0 and y as 0, then that function will be again 0. Next what we have to take is the function with respect to y. The function, if we take this function with respect to y, if we take this function with respect to y, this function with respect to y means differentiation of sin y is cos y, and this will be constant, we can keep as it is, e raised to x cos y, e raised to x cos y. Then if you substitute this x as 0 and y as 0, this will be 1 and cos 0 will be 1. So your value will be here 1. So now again what we want here, again we want f, again we want this term. So again we will differentiate this given term. Now if we differentiate this, now this will be differentiate with respect to y, then this will be minus e raised to x sin y, minus e raised to x sin y. Then your function will be, if x is 0 and y is 0, if you substitute 0, this means it will be minus 1. So if you substitute y as 0, then the whole term is 0. Then the whole term is 0. Next function, again this function with respect to y. This function with respect to y means it will be minus e raised to x cos y. Now this function will be 0 at function x as 0 and y as 0. If you substitute x as 0 and y as 0, cos 0 means 1, here e raised to 0 means 1, it will be minus 1. So now we have found the values of fx, f double x, f 2 times of x, f function with respect to 3 times with respect to x. Now again we want here f with respect to x and y, f with respect to x and y, that is the function with respect to x and y, function with respect to x and y, the function with respect to x and y. This function with respect to x and y means already we have found the differentiated the function with respect to x. Now we have to differentiate this function with respect to y. Function with respect to y means here e raised to x will be constant, we will write as it is. Differentiation of sin y will be cos y, sin y will be cos y. So this function, that is function xy with respect to x and y will be, if you substitute x and y as 0, this will be 1, because cos 0 is 1 and e raised to 0 is 1. So next what we have to do here is, we want here this function again with respect to y. So we will find this function again with respect to y, function again with respect to y. The given function again with respect to y means this will be minus e raised to x sin y, minus e raised to x sin y. Then this function will be, if we substitute x and y as 0, this function will be 0. Next we want the function, that is this function, that is f 2 times with respect to x and 1 time with respect to y. Again we have to differentiate this function with respect to y, this function with respect to y, that is function with respect to y means, if you differentiate this function with respect to y, differentiation of sin y will be cos y, that is e raised to x e raised to x cos y. So that we can write it as f of 0 comma 0, this will be 1. So now we have found this much of values. Next what we have to do is we have to substitute the founded values in this equation. So that is f of 0 comma 0 equal to f of 0 comma 0. Here what is f of 0 comma 0? F of x comma y. Here f of 0 comma 0 is 0 plus fx of 0. Here this fx of 0 is 0. This fx of 0 is 0 here. So this whole term will be 0. Next plus y into fy. Fy, this is fy. Fy is value is fy of 0 comma 0 is 1. So we can write this y into 1 plus 1 by 2 factorial plus 1 by 2 factorial. F 2 times with respect to x. F 2 times with respect to x is again 0. This value will be 0. Next function plus 2xy, function xy. xy is 1. So we can write this, that is 2xy into 1 plus y square. Function 2 times with respect to y is 0. So this will be 0 again. Plus 0 plus 1 by 3 factorial plus 1 by 3 factorial. Function 3 times with respect to x, that is 0. So this term will be 0. This term will be 0. Next 3x square y. Function 2 times with respect to x and 1 time with respect to y. Function 2 times with respect to x and 1 time with respect to y is 1. Function 2 times with respect to x and 1 time with respect to y, this is 1. So we will write here, that is 3x square y into 1 plus function 1 time with respect to x and 2 times with respect to y is 0. Then now this will be 0. This will be 0. Next function 3 times with respect to x. Function 3 times with respect to x is minus 1. So we will write this as minus y cube. We will write this as minus y cube. If we simplify this, then we will get, that is function f of x comma y. Function f of x comma y is nothing but e raised to x sin y. E raised to x sin y. Next, that is y plus 1 by 2 factorial. Y plus 1 by 2 factorial into 2xy plus 1 by 3 factorial into 3x square y minus y cube. 3x square y minus y cube. Now again we will simplify this, that is y plus xy, y plus xy plus 3 factorial means 3 into 2 into 1. That will be 3 to the 6. That is 1 by 6. 1 by 6 into 3x square y minus y cube. 3x square y minus y cube. That will be y plus xy plus, if you multiply this, 3 1s are 3 2s are 6, that is x square by y 1 by 2 x square by y minus 1 by 6 y cube. This is the solution for e raised to x sin y. Y plus xy plus 1 by 2 x square y minus 1 by 6 y cube is the solution for the given maclaurins form. So thank you. We will continue with some more problems in the next video.